All right, so I'm going to be talking about JSON Web Tokens as mentioned, and we will do a little bit of code, looking at code later. That's a sneak peek. Um, but first, real quick about my employer. I am doing this on my employer's dime, and I've learned a ton working at FusionAuth. So I'm just going to give them a quick pitch, but I promise you this is not a vendorware talk. This is about the only time that I mentioned FusionAuth. So we basically are a CIAM, which stands for Customer Identity and Access Management. We're very similar to Auth0. We're different in that we're self-hostable and API first. So basically, we also have a free edition you can download and run yourself. And people are running it with millions of users, and we don't see a dime as long as you run it on your own hardware. If you want us to run it for you, it's a different story. Anyway, go check out FusionAuth if you want to. We create a lot of JSON Web Tokens. Real quick about me, who cares? You didn't come here to learn about Dan Moore. You can look me up online, but if you want to learn more. If you have questions, Scott's going to be gathering those, so I think we're going to save them to the end. So feel free to type them in the chat, or any other way that you want to get them to Scott, carrier pigeon, or whatever, and we'll make sure to look at them at the end of the presentation. A real quick giveaway. Actually, I didn't check with Scott if this would be okay, so I'm kind of just winging this, but there's an ebook called The Modern Guide to OAuth that I co-wrote. It's about 80 pages of OAuth and OIDC goodness, and I'm happy to give that away if it's in line with CFE Dev's rules. So if not, then sorry. So we'll determine that kind of at the end of the presentation. What I'm going to talk about. Okay, enough housekeeping. Let's talk about JSON Web Tokens. I'm going to talk about JSON Web Tokens and kind of a little bit you need to know about them, kind of some of the history, the problems they solve, how to validate JSON Web Tokens. This is something we see that's a little bit problematic, is some people don't do the full level of validation they should. We'll talk about bearer tokens in general and some of the issues that they have and how to remediate them. We'll talk about some common issues that we see with JSON Web Tokens and some things that people do that probably shouldn't. We're going to then branch out a little bit and talk about refresh tokens, which are related to JSON Web Tokens, but not the same. And then we'll talk about JSON Web Token revocation. So let's dive in. So JWT stands for JSON Web Token. If you look at the specifications, it's actually pronounced JOT. So if you want to be in the in crowd, you can, next time someone's talking about JSON Web Tokens, you can say, let's look at that JOT and see how it was signed. It's a standard. There's one of a set of like standards around the RFC 7519. I think 16, 17, 18, 19, 20 are all related, and they're all about tokens and signing and some encryption. So they're kind of, it's a part of a family of specifications that the IETF did. I think it was about 7 years ago, 2015, 2016, might have been 2017. But one thing that's really worth knowing is that JSON Web Tokens, or JOTs, can be either signed or encrypted. So whenever you're looking at a JSON Web Token, that's the kind of the first question you're going to ask. And the difference between these is that a signed token, you can know the integrity of, because it's basically signed. And we'll talk a lot more about that in coming slides. But the contents of the JSON Web Token are not secret. So you can tell that it hasn't been changed, but you can't put in like, or please don't put in like a social security number or government identification number into a JSON Web Token that is signed. Encrypted JSON Web Tokens, on the other hand, as the name implies, the payload is actually secret. It's encrypted. I will say that in my years with FusionAuth and before, seeing encrypted JSON Web Tokens, it's rare enough that I actually tweeted about it. It just doesn't happen that often, whereas signed JSON Web Tokens are pretty much everywhere. I see them in a lot of places. So I'm going to focus on signed JSON Web Tokens because that's just much more common, but just be aware that there are those two things. And the most important takeaway from this point is if you have a signed JSON Web Token and it contains a secret, you need to remedy that, right? Either turn it into an encrypted JSON Web Token, figure out some way to not include that secret, because anyone who gets a hold of that JSON Web Token can see that secret. So JSON Web Tokens are often used as stateless portable tokens of identity. What do I mean by that? They're stateless because they can be verified as being accurate and not having been tampered with without ever communicating or without like passing them to a server and saying, hey, is this JSON Web Token okay? Is this JWT okay? They're portable because they are very friendly to HTTP. They can be put in form parameters. They can be put in headers. They can be stored in cookies. And then when I say tokens of identity, they're often used at the end of an authentication event. This is certainly how FusionAuth uses them, and they represent the user. And so then they can get passed to other systems, and the person holding the token can usually be determined to be the person who authenticated. The reason we use the word usually is there's some kind of caveats around that, but that's how they're often used. Because of that, they're great for APIs and microservices because you can basically generate a JSON Web Token at one place. You can pass it to a client. The client can pass it around, present it to APIs or microservices, and get access to data or functionality on behalf of that user. And the API or microservice can validate that JSON Web Token and know and basically assume that the holder of the JSON Web Token is the person for whom the functionality should be available. It's also produced by a lot of identity providers. FusionAuth is not alone in that, right? I know Auth0 does. I know there are other identity providers out there. Firebase, I think Cognito does. So it's a standard. There's a lot of support out there for that, right? Not just in terms of the identity providers that I just mentioned, but in terms of documentation, in terms of libraries, in terms of understanding of JSON Web Tokens, it's a lot more prevalent, in part because it's just been around for a while and it solves this really important problem of distributed identity. Speaking of problems, let's talk about the problem that JSON Web Tokens are designed to solve. So here we have your traditionally vastly over-engineered to-do application. So on the left here, we have clients, right? It could be a browser, it could be a native client, it could be something else. And then we have our APIs that those clients communicate with. And then there's a data store that the various APIs use. The data store for the user API looks pretty typical. We have users, we have roles, we have a mapping between them. In the to-do API, we just have to-dos. So this to-dos table has some interesting things, right? It has like a text field for the to-do, a status that we're going to probably use an enum for, and then we have a user ID. And that user ID, an important thing to note about this is that because we're in a distributed system, that user ID can't be a foreign key. So it's going to be not null because we're always going to stuff a user ID in there, but it can't reference back to the user table that we previously saw because you can't have foreign keys across databases. So in our over-engineered to-do application, how are we going to get access to to-dos? Well, we obviously are going to start out with do some kind of authentication ceremony, right? So we're going to post conceivably a username and password. It could be other means of getting access. We're going to post that to the user API, and then let's see what happens after that. So this is the problem. The problem is, how do we tie the to-do API, the to-dos, back to the user after that login event? So again, log in the user API, and that user API is going to consult the user's database, and it's going to get back a user and some user data. And frankly, for JSON Web Tokens for developers, you don't really care what happens. You don't care how many times that password is hashed, what algorithm was used, anything like that. At the end of the day, you're getting back a user object, and it's probably going to be JSON in a modern web application. It could be something else, and that's going to get passed to the client. It might look a little bit something like this, right? We have a user object, we have an identifier, name, roles, email, other information might be in there as well. Then, because we have user ID 42 and we're a client, we're going to say, hey, I need to get the to-dos for the user ID 42. I'm going to pass that identifier back to the to-do API. The to-do API can go look in the to-dos database and say, oh, Dan has 25 different to-dos. I'm going to wrap them up as JSON, send them back to the client. Client gets to render them. Is this a good idea? Spoiler alert, it's actually not a good idea. And the reason for that is that you can't trust the client, right? You just cannot trust a client. And so someone could see, basically look at what the client, the request the client is making, either via examining the code on the native app, or they could look at the network traffic, depending on how they wanted to, but they could see that you're getting a to-do with a user ID of 42, and that tells them a couple of things. The first thing, it tells them that there's probably at least 42 users in the system, which is information you might not want to leak. And the second is it lets them iterate over them, right? So you could start a to-do of user ID 1, get all the to-dos of user ID 1, and then user ID 2, user ID 3, et cetera, et cetera. Obviously, that's a really bad idea. So we need to do something to the to-do API to make sure that it's not blindly accepting user ID, the user ID that's passed to it, and handing back the to-dos for that user, because we need to keep those private. So let's talk about a couple of different approaches we could take. The first we could do is what I call the opaque token approach. And so in this scenario, what you do is you have the user API generate not just the user data, but they generate like a long random string. And they pass that to the client, and the client is coded to know, hey, don't present the user ID to the to-do API, present the token. Now, the to-do API gets that token, and it needs to do something with it. It cannot just use that token and look up a token in the to-dos, because you're still, while you've solved the first problem of knowing that there are roughly 42 users, or a malicious client knowing there are roughly 42 users, you haven't solved the enumeration problem, because no matter how big that string is, it could be that someone else is going to rent a fleet of EC2 instances on AWS and run through every possible value of that token and basically scrape all those to-dos. So the to-do API cannot use this opaque token as an identifier in the to-dos database. What it needs to instead is present that token to the user API. Now, the user API can, because it generated that token, it probably stored it in a database, it can say, oh, this token is valid. And so I'm going to hand back the user ID, or just hand back the entire user object. And then that the to-do API can pull off the user ID and then look up the to-dos. If the to-do API presents that token and the user API says, whoa, guy, whoa person, don't, this is not a valid token, returns a 401 or whatever other SAS code it wants to, then the to-do API knows that someone was fooling around, someone was messing with that token, and that's either a bug or an attempt at privilege escalation or something, and the to-do API should not return the to-dos. So this approach is a totally valid approach. You have to, like any engineering issue, there's trade-offs. You have to maintain a user token mapping at the user API, which, depending on the number of users, could be trivial. It could be a really big problem. It can be very chatty, because every time the to-do API gets a request, it has to present that token to the user API, unless, of course, it caches some things, which then you're introducing some other complexities. And basically, basically, kind of the bigger issue from an architectural standpoint is that it couples the user API to almost everything. So anytime there are requests coming in from any APIs that are related to a user, you're going to need to extract that token and present it to the user API. That's fine if you have 2 APIs or 3 APIs. If you end up having a large number of APIs, you end up having to scale up the user API significantly. One thing that's worth noting is this kind of flow is OAuth introspection. So this is an IETF blessed RFC. There's the number up there if you want to read it. So totally valid pattern for determining the validity of a client request, basically. I should say it's actually not exactly OAuth introspection. It's very similar to it, because OAuth well, no, I'm wrong. Actually, it is exactly OAuth introspection. So JWTs are an alternative solution to the problem that we've just illustrated. So with a JWT, the user API generates a JWT similar to the way it generated an opaque token, and then it passes down the information to the client, and then the client can extract that JWT and present it to the to-do API. The nice thing about this is the to-do API can now look at that JWT and determine who signed it, when it was good for, who it was for, and other attributes without ever talking to the user API. So a JWT can be signed with a public-private key pair or a symmetric key. We'll talk a little bit more about that difference in the future in future slides. But this is the big win, right? The second point. The to-do API never has to talk to the user API because the token has been correctly signed. Another win is that a JWT can contain a lot of other information. It doesn't have to just be kind of a binary yes or no, or just a user ID. It can contain roles. It can contain stats about a subscription, plan information, whatever else you might want to have about a user. Again, with a caveat that anyone who gets their hands on that can see the contents. So you might not want to put anything that's secret in there about the user. So let's take a look at actually what a JWT looks like. So enough boxes. Here we have a signed JSON Web Token. It has three parts. It has the green part, which is the header, the blue part, which is the body or the payload, and then, the white or tan part, which is the signature. The header and the payload both are basically base64 URL encoded strings. That's why you'll recognize whenever you see EYJ0, that is the kind of start that's base64 URL encoded, I think it's J0, of a curly brace. Might be just EY actually. But anyway, so you can decode these. If you just Google for base64 decoder, it's going to work most of the time. I think URL encoding changes a few things. But this is a header right now, and this basically has information about the JWT that's metadata. So this is the algorithm that was used to sign it, the type of the JSON Web Token, because you can have multiple different types. Sometimes there's a key identifier in there to determine which key was used to sign it. The body is where things get interesting. And so, as I mentioned earlier, you can put whatever you want in a JSON Web Token. It's just a JavaScript, or it's a JSON object. So the keys of the JSON object, because identity geeks like to use jargon, are called claims. They're claims about the user. And some of these claims, some of these keys are standardized and others are not. Issuer is issuer is standard, expiration exp is standard, audience is standard, AUD, sub is standardized, but the last two are not. Name is not standardized, and roles is definitely not. And you can basically put whatever other objects you want that might be helpful to your downstream JWT consumer, right, to the to-do API. One other thing worth noting here is that the roles show that it's not just primitive values that you can store in a JWT. You can store arrays, you can store arrays of arrays, you can store arrays of objects of arrays, whatever you want. One question that often gets asked when I give this talk is, how long can a JWT be? And the answer is, there's no limit on the JWT. There is a limit on the transport layer. So if you're passing a JWT around as a header, and there's a length that some browsers impose on a header, that limit is the limit of the JWT, right? If you're passing around as a cookie, then you're gonna be limited by the size of a cookie unless you take steps to kind of like break it apart and put it back together again. Finally, there's the signature. And the signature is a really, really important part of a JWT. Chances are very high that you're going to just use a library to generate the signature, but it's worth understanding kind of what it does. Basically, you take the header and the body or the payload, and you run a cryptographic operation over it, and then you base64 URL encode the output. And the particular kind of operation varies depending on what algorithm you use. Again, symmetric algorithms are different than asymmetric algorithms, but chances are, again, you're going to use a library to do this, but it's important to know that because you run this cryptographic operation over the header and the body, which is specified in excruciating detail by RFC 7519, then that signature will be tied to the header in the body. And if anyone tweaks the header in the body or the body, right, to give themselves a different role, for example, then the signature will no longer match. Which leads us to JSON Web Token validation. Is the things that you need to do as a developer when you receive a JWT. So again, this is the To-Do API or any of the other APIs that you might write that take that JSON Web Token from the client and are protecting. I mean, remember, the To-Do API is protecting my precious to-dos of like going to the store to get milk and making sure I walk the dog. I want to make sure that only I can see those to-dos. And so we need to make sure that we validate this JSON Web Token to make sure that it is tied to the correct user. So the first thing you need to do is validate the signature. And my advice here is just simply use a library. I have not seen any major languages, programming languages that don't have some kind of JSON Web Token library, preferably an open source one, to be totally frank. If you reuse a library and you provide it with the needed parameters for to check the JSON Web Token, and it gives you any kind of exception or error or says, hey, the signature doesn't match, stop. You can stop processing because something's gone awry. Again, either a bug or a privilege escalation or something else going on, but the JWT you presented is not the JWT that you should, is not a valid JWT for you to keep moving forward with whatever the API call was. The next thing, excuse me, and this is where I have found that some people don't fully do this, is you need to validate the claims. You need to validate the values of the keys of that JSON object that come in after the signature has been checked. This is business logic to some extent, right? There are some libraries that will help you with some of the claims, but if I need to make sure that only the only people who have access to my To-Do app are the people who have paid, I might put a claim in the JSON Web Token that says, paid user of true if they've logged in and they are paid. That's business logic to know what attribute I'm looking for in the To-Do API. So that means you need to write it. That doesn't mean that you need to write it for each individual API. It's possible you could make it into like a custom library or module or something like that, but you're going to have to write this logic. So here's our payload. We have an issuer, we have expiration time. What are the things you need to check? Well, as I mentioned, some things are standardized and some things are not. Here, we need to check the issuer to make sure that this JWT was created by the person or thing that I thought created it, right? So that's, again, my user API in this scenario. So that means that we want to make sure that the To-Do API knows who generated this JSON Web Token. We also need to check the expiration time. And this is the number of seconds since the Unix epoch. And if this is in the future, your JWT is most likely valid. If it's in the past, your JWT is not valid and you should just stop going forward. It's just the same as if the signature validation failed. The audience claim is another thing you should check, and this is who the JWT was created for. So in this scenario, the To-Do API is the thing that the JWT was created for. And so if you get an audience claim that is not what you expect, you should stop processing. Why is this an issue? Well, it's possible that you might have multiple different APIs that are being called and different user roles for each one. And so if someone's an admin in the To-Do API, that might grant them, access to like seeing other people's to-dos. If they're an admin in the accounting API, it may give them the ability to like send out a check. So you don't want a JWT that's created for the To-Do API to be presented to the accounting API and give escalated access. Let's look at a little bit of validation code. So here is, and this is, there's a link to it at the end of the presentation. This is some JavaScript code that presents kind of a simple validation scenario. So we have lines 3 through 17, we're pretending is the user API, right? So it's going to do some other things and log people in, you know, login assumed, but we've assumed we've already authenticated the user to some extent. Now we're just creating a JSON Web Token and we're signing it. So we are asking in a couple of different claims, and we are on line 9 making sure that it is good for 5 minutes. And then we're going to print it out to the console. Again, in the real world, you would send this down as a cookie. Typically, there are other options as well. And then lines 19 on, we're actually pretending we're the to-do API, right? Where we've received this token, and now we need to process it. And so the first thing we do is this particular library lets me check the expiration time in the issuer. And so that's what I'm doing on lines 21. I'm basically just setting up the library. On line 27, I'm having it verify the signature, and it will also do that additional verification around expiration time and issuer. And then lines 29 through 34 are my business logic, right? I'm checking the audience claim. I'm checking that there's a premium user value. And I'm going to throw exceptions if that's not the case. In the real world, you'd want to, again, send a 401 or some other kind of more sanitized version of the problem, but this is demo code. And then line 38, I am going to print out the verified object. So let's go ahead and run it real quick. You can see I get this JSON Web Token, EYJH. So yeah, EY is the base URL encoded curly brace. I get this, and then this translates back to in my to-do API, I can see that I have all this information. If I do this again, I get a different, same header, different payload, different signature, because the time has changed. If I change, let's just change let's change the HMAC key. So we're going to do this. We're going to do const new HMAC key. So this is where the signatures don't match, or this is a way to show what happens when the signatures don't match. Because some nefarious person is creating a JSON Web Token using this library, and they think they've found the signature. But this is the real signature that has been distributed through my secrets management system. WE, invalid signature. So that's exactly what I want to have happen, right? Because the fact that the signatures don't match means that I can't trust the integrity of the JWT, which means I can't trust the integrity of the user, and therefore I shouldn't give them any access. So there's a bunch of other examples here. I haven't touched them for a while, but you can see you can deal with like um, you can see HMAX in kind of various different ways. And like I said, I have some other examples in different languages, but that's the JavaScript example I have. So let's look at bearer tokens, right? So we've kind of seen why you might want a JSON Web Token from an architectural standpoint. We've seen kind of the nuts and bolts and the skeleton of a JSON Web Token. We've looked at validating JSON Web Tokens. Let's talk about bearer tokens in general. So bearer tokens it's a bigger thing than JSON Web Tokens, than JWTs. JWTs tend to be used as bearer tokens, but you could have a bearer token without it being a JWT. The whole idea of a bearer token is that you have it's something for which the possession of the item is proof that you have access. That's a bit of a mouthful. So the way I always think of it as an analogy is a car key. Unless you have a fancy schmancy car key with a biometric sensor, if someone holds the car key, they have access to the car and can drive the car. So that means that you need to be careful with the key, because if you leave the key in the car or next to the car, someone else, your neighbor, someone walking down the street can pick up the key and get in your car and drive off with the car and, get access to that valuable functionality of being, driven around in your fancy schmancy car. So in the world of JWTs, what that means is you need to protect the JWT that is issued by the user API, because if a bad actor gets the JWT, as they do here, they can present that to the to-do API, and the to-do API will say, oh, cool, this is a valid JWT, because the bad actor didn't create a new JWT, they just stole an existing JWT, right? So the to-do API will say, that's a valid JWT, I'm going to hand back those to-dos, just as if Dan himself had handed me that JWT. So that means that when you store the token, and also when you ship it around, you need to be careful about what you do with it. So as far as like securing a token in transit, HTTPS is kind of the gold standard. If HTTPS is ever found to have holes in it, we're going to have a whole lot of problems. But definitely, and also don't put JWTs that are sensitive in URLs. Because URLs get cached as a query parameter. Anyway, so token storage, basically we recommend server-side storage typically. It does depend because your use case could vary. We also recognize that sometimes you want to send it down to the client. If you're using a browser as a client, you want to make sure that you store it as HTTP-only secure cookie. That removes a whole class of cross-site scripting issues. Whereas if you store it in local storage, then any JavaScript on your page can access that access token and send it off to a server in country XYZ, and then that server can make requests based, basically masquerading as the user, right? That's one of the main threat vectors with JSON Web Tokens. If you have a native client instead of a browser, then you're going to want to use like a secure storage option like the keychain, or I think Android has something called secure storage. So you just want to make sure that people, like other malicious software, either executing the browser or executing on a native device, don't have easy access to this access token. So let's talk about some common issues that we've seen with JSON Web Tokens and implementations thereof. So first, I'm going to keep hammering this home. You have to validate the JSON Web Token. You can't just look at the signature. You have to validate the signature. You have to check your claims, both the standard ones and the custom ones that are business logic. So please do that. You also want to make sure you don't put a secret in a JSON Web Token. Again, it's base64 URL encoded JSON. The integrity is guaranteed, and not secrecy. Again, this is more for the signed JSON Web Tokens. Encrypted JSON Web Tokens are a different ballgame. Again, not super common, so I'm not going to address them. The other thing that's maybe also of interest is that you can leak information from a JSON Web Token even if you don't put any secrets in there. What do I mean by that? Well, you may have noticed that the audience claim of the payload we looked at was not a number. It was a GUID. It was a UUID. That's because if you put in a number, then suddenly an attacker knows something, right? Because there's no secrets in a JWT. So if you put 42 for the audience ID or for the subject claim, which is basically the user ID, then suddenly people know, well, there's at least 42 users probably. And so therefore, you just want to make sure that you're aware that a JWT can definitely leak information. If you use symmetric key signing, which is the HMAC signing, which is what I showed here in the code, that's where the secret is shared between the entity signing the JWT and the entity verifying it. But because of the way it's built, you can actually brute force that and find the secret with nothing more than the JSON Web Token. Basically, you just like redo that cryptographic algorithm time and time again and see whether the signature matches the operation with a given secret, right? Like you try secret A and you run the operation over the header and the body, and you see if the signature matches. Then you try secret B, secret C, yada, yada, yada. There's a little GitHub project right here, which does this in C. If you use a HMAC key of like length 4, it's going to solve it in like 30 seconds. If you live HMAC with a length of 100, it's going to take a lot longer. You're probably going to hit Control C before that ends. You don't want to use the none algorithm. So we talked a little bit about signing algorithms in the header metadata. But the none algorithm basically says, hey, I don't want any signature on this JSON Web Token. That means that there's no integrity check, which basically means that anybody who discovers your API that accepts this JWT with no algorithm, with no signature, can basically create whatever payload they want, base64 encode it, and present it to your API. This is a totally valid JSON Web Token. So you can think of this as like unsanitized credentials, right? We've always been told don't accept unsanitized user input, but this is even worse. This is unsanitized, hey, this is who I am. So don't ever accept the none algorithm. Let's talk about asymmetric key pairs versus symmetric key pairs a little bit. So we have here a JSON Web Token that's generated from the user API. It's passed the client. Client presents it to the to API. As I mentioned before, one common algorithm is called HMAC, and that means that the user API and the to API share a secret. And the user API uses it to sign it. The to API uses it to verify it. You have to have some way of distributing that secret securely, some way of rotating that secret. And you also have to secure the to API in this situation. So one thing you can do is, just distributed deployment time. Maybe you distribute 10 secrets, so you have some kind of rotation capability. But asymmetric key pairs avoid this kind of deployment complexity. And with asymmetric key pairs, the private key, this is like RSA or elliptic curve cryptography, the private key signs the JWT and the public key verifies it. So this is helpful for a couple reasons. One, it lets you scale out situations a lot more. You can imagine sharing a secret between, a small dev team that's maintaining 2 or 3 APIs, not a big deal. On the other hand, if you have 2 different companies or 2 different departments, then sharing a secret becomes a much bigger deal. So in this situation, we have Pied Piper that owns the user API, and then Hooli owns the to-do API. And basically, the user API generates the JWT, signs it with that private key, and then passes it to the client. The client presents it to the to-do API, which can get the public key, because the public key is public, and then verifies the JWT. That means that this can scale out to adding in, other organizations, including ones from different movies or different TV shows. The other reason why this matters is security. I kind of alluded to this, but the thing that is used, if you're using a symmetric key pair, the thing that is used to sign this JWT is the same that is used to verify that JWT at the to-do API. That means that suddenly your attack surface is much bigger, because you have to make sure that everybody that is verifying a JWT is secured to the same extent that the user API is secured. Because if anybody steals that secret, then they can sign JWTs that are indistinguishable from those that are signed by the user API. So again, that means that if someone steals that secret, until that shared secret is rotated, they can sign JWTs giving them whatever access they want, right? They can create their own custom payload observing your API traffic and give themselves super admin access or whatever else they can get access to. So you might say, well, Dan, why would you ever use symmetric signing, right? It seems like the security implications, if nothing else, are a good reason to not. The main reason is that it's slower and it's more complicated to understand. That's a big reason. Like I did some benchmarks. It's been a year or two, but the asymmetric key pair was between 3 and 10 times slower. So if you're processing a lot of JSON Web Tokens, that trade-off may be worth the deployment hassle. To share public keys, you have a couple options. You can use a standard, or you can distribute the keys. Basically, the to-do API here, if you're using an asymmetric key pair, the to-do API needs a public key. You can distribute it as part of the deployment artifact. Again, you can put 10 or 20 different public keys in there. It's different than distributing the shared secret, because if someone steals the public key, they break into the to-do API, steal the public key, no one cares, right? A public key is public. But a more common situation is for you to use the to-do API to request a well-known endpoint. This is another standard. This basically is a list of keys, and there's a lot going on here. The important bits are right here. The algorithm of the key identifier, and then the actual public key, which starts with MII. And this key identifier, which starts with UK0, matches the key identifier in a JSON Web Token, very typically. So as you're processing this this request at the to-do API, you're going to look and see, and again, some of this will be handled by a library, but you'll look and see what the key identifier is, and that's going to tell you which public key to use to verify the JWT was signed by the corresponding private key. Refresh tokens, and I know I'm running out of time, so I want to make sure I have definitely time for questions. So I might move through this a little bit quicker, but refresh tokens are basically exist because JWTs, especially when used as access tokens, are meant to be short-lived, like seconds or minutes. Refresh tokens can be long-lived, and refresh tokens are basically presented to the user API to create new JSON Web Tokens. So they exist because if you imagined a world without refresh tokens, then you have two pretty appealing options. The first is when an access token is short, right? If you follow the recommendations and you keep your access tokens or your JWTs to have a lifetime of like 5 minutes, then anytime that access token expires, suddenly the user has to log in again, which I don't know about you, but I probably wouldn't use a service that made me log in every 5 minutes. The other option is you say, screw it, I'm going to have my JWT be good for a month. That means that, yes, the user doesn't have to log in regularly, but like if someone steals that JSON Web Token, anyway, they have like a full month to or they have a long time to pull down the data, to probe, to use that JSON Web Token. So the way a refresh token works is that you actually request it when you start the authentication process, and then it's sent down along with the JSON Web Token. And again, the JSON Web Token is presented to the to-do API, and then there's data sent back, right? So, and this kind of pattern happens for the lifetime of the JSON Web Token. Eventually, the JSON Web Token will expire, and the to-do API will say, hey, hold your horses. No, you don't get any more access to my to-dos. The client can catch that, and then they can present the refresh token up to the user API. The user API can say, oh yeah, this user hasn't logged out. This user is still valid. This user has paid their bill. I'm going to issue a new JSON Web Token. And this orange JSON Web Token is sent down to the client. The client then can present the JSON Web Token to the to-do API, which can then validate it again. It's good for another 5 minutes, yada, yada. So we basically re-authenticate the user in a silent manner. As far as logout in a JSON Web Token-based system, in a JWT-based system, you're pretty much limited to revoking the refresh token. How that works is the client, when the user clicks the logout button, they fire off a message to the user API saying, hey, don't issue any more JWTs for this given refresh token. And then they delete them from their, the client then deletes them from their storage. Actually revoking the JWT itself is a different ballgame. And the answer we get when people say, hey, can you revoke JSON Web Tokens? It's kind of. You can't really. There is a RFC out there, 7009, which allows you to revoke a refresh token. But if you use that particular specification, then you basically lose the ability to I want to put this carefully. You basically have to check back in with the user API. So you're basically back in the opaque token world with maybe a little more standards-based and more flexible token, but that's really about it. Another option is you can rotate the keys, and that would work if you had like a huge break. Like I think GitHub a couple of years ago, or maybe a couple of months ago, logged everybody out. And I don't know if that was a some kind of security thing or what it was, but like that, essentially, I read that as they rotated their keys because maybe one of the keys had been compromised or something like that. I don't know. I shouldn't say that about GitHub. I don't know the details of it, but if you rotate the signing key, then when the public key is retrieved, it won't match, right? Because if you remove the public key, imagine a JWT was signed by public key A, then you later remove that public key A from your list of public keys. Now it's not going to be able to, the library is not going to be able to find the valid public key, and so the signature check will always fail. Another option is to have really short lifetimes. We've seen people who have lifetimes of seconds, which basically makes the JWT like a one-off thing. A third is the deny list. And the way this works, and this is Fusion specific, but I've definitely seen it implemented in other libraries and other situations. Basically, when someone logs out, we fire off an event, and that gets sent to a bunch of different APIs. And it says this refresh token has been revoked. Okay, and then make note of this. And then the to-do API stores that information and says, okay, this user now has basically logged out. So if I see an access token that's tied to this user, I should refuse to give any data for that particular user at that time. Some alternatives, you can use web sessions. I think JWTs pair nicely with those in terms of server-side storage. Web sessions have their own kind of costs and benefits. You use cookies. It's less scalable in a lot of ways. You kind of have to have everything routing through a central area, but it is simpler to understand. So in conclusion, I think JWTs are a great tool to have in your architectural tool belt. They are not a panacea. They have trade-offs and strengths and weaknesses like any other solution. So some additional information. We have a JWT debugger. We have that sample code I mentioned. I have a couple of different articles if you want to read a couple thousand words on JSON Web Tokens. And there's another pitch for the Fusion Auth Community Edition, which is, again, a free authentication authorization server. If you have any questions, I'm happy to take them at this time.
All right. Thanks, Dan. That was great. I feel like I learned so much there. And I have a ton of questions. First one here, could you go back? I'm sharing your screen just for a moment. Can you go back a slide? And we had someone who was looking with the one with all the links for your
the links.
example.
Yeah, of course. Yeah, this one.
All right, just going to keep this up for a moment here.
Sure.
Someone had some questions about the usage, and I felt like your code example kind of nailed that. So I'll leave these up for just a sec here while I ask the other audience question, which was just to clarify here. So it came in a little bit earlier in the presentation and was asking if the key needed to be shared, the secret key needed to be shared among all of the different services that you're using on the server side. And what I got from that was, it sounded like yes, but that's a challenging problem to solve, especially if you have larger teams, so that you're recommending, usually if you have multiple services, you would look to implement the asymmetrical key pattern.
Yeah, I think that's a fair statement. I think that when you get started with JSON Web Tokens and you're playing around with them, it's so much simpler to understand a shared key. But the question asker nailed it, right? Like, it is any kind of shared secret between different services gets a lot harder when you have more and more services. So in that scenario, I would say move to an asymmetric key.
Okay. That makes sense. All right. And I had a couple questions here myself. One was, so you mentioned a few times the difference between signed tokens and encrypted tokens, and it was interesting to me because it sounded like there you had to be more cautious using a signed token, but they're also much more popular. Do you have a sense of why? Why, if encrypted tokens are more secure, why aren't people using them more?
Sure. I would think that so this is just based on anecdata, right? I don't have any good, I haven't had like a deep discussion with anybody, but I think that signed tokens are easier to implement. I think they're faster to process. I think that you don't, when you have a signed token, you're kind of not worried about how people get the key to decrypt the encrypted content. So
Okay,
those are kind of the pieces that I would think of.
that makes sense. Makes sense. Now, are there instances where a jot would not be a good choice? I mean, you said there's trade-offs. Are there? Can you think of an example where you like, yes, I definitely wouldn't use it in this case?
Sure. I mean, so yeah, I think an example that is kind of close to this presentation is the To-Do API, right? Like, I think that the To-Do API could just use a API key, right? And if you didn't need key rotation or other things like that, and it was a pretty simple API, a simple string that doesn't have any other information in it is kind of going to be enough to kind of indicate that the user is, or the client is, who they say they are, right? If it's an internal app or something like that. That's an example. I think it's another example of where JWTs would not be a good fit. Um, I think if you need to store something in local storage for whatever reason, or you can't find a secure location, then you want to like look at a different class of solutions that tie the token, whether it's a JOT or not, to a to the client more tightly. And an example of that, there's a couple of standards people can look at. One's called Depop, which is actually moving through and is about to be an RFC. The other is called MTLS. And those, right? Remember, I used the analogy of like a car key, right? Like
Hmm. Hmm.
um, Depop and MTLS are a way to like actually create a biometric car key where it is tied to the client, and the client owns something that it presents to the server in addition to the token. And so you can be absolutely 100% positive that it is that client, not some server in country XYZ.
Gotcha. Okay, but until then, it sounds like it's a bit more identity based. If you just need basic information from an API, some sort of service key is probably good enough in a lot of cases.
I mean, it depends on like how big the team is and whether you have other infrastructure set up that already leverages JOTs. But yeah, I mean, certainly I've written APIs where it was just like a key in a database, right? Or not a key, it was an API key that was a field in the database, and that's a perfectly fine way to go. Um, the joke I always say is like, well, then you start, your security team comes in and they want, well, we need key rotation, and then you're like, oh, and we need refresh tokens, oh, or some way to refresh this API key, and then we need more information than we have in just a string. We need to encode a JSON object, and then you're like, congrats, you've just reinvented OAuth.
Yeah.
So, but again, if I was like a 2-person startup or a 5-person startup and I was just trying to get stuff shipped, I would definitely look long and hard at just plain API keys.
Okay. Okay. And so you talked a little bit also about storage methods for the token on the client, and said that you generally lean towards using cookies and secure cookies. Is there a scenario where you might, whether it's local storage or whatever, that you have a preference for another approach?
Yeah, so this really comes down to your threat model, right? Like if you are using JOTs mostly for protecting APIs that are kind of publicish anyway, and you're just using it to like track stuff and make sure they're not abused, then you could conceivably put it in local storage. if you but I mean, if you audit all of your JavaScript and you're 100% positive that there's no possibility of some malicious JavaScript getting in your page, maybe your local storage is okay. I know Amplify, for example, uses local storage. I think it's a pretty common pattern with a lot of kind of client-side JavaScript libraries. That where cookies fall down, where cookies fail, is that the cookie gets sent along to any requests on the same domain, right? So if I set a cookie to have a domain of example.com and my API is at example.com and I have another API to do api2.example.com, then I get, because of browser semantics, I get like the cookie, the access tokens get passed around for free, right? With no effort on my part. But if I want to make a call to, to-do.com, suddenly that cookie doesn't get passed. So that's where this is a really great pattern for kind of an enterprisey kind of thing, or something where you control both sides of the scenario. But if you are writing a browser app and you need to call Google's APIs and somebody else's APIs and somebody else's APIs, well, you're not gonna be able to set a cookie to match all those domains. So the alternative there that we recommend is a proxy. But I think that is where the local storage comes from, is because it's very easy for a JavaScript client to pull the value out of local storage and put it into a header and make a fetch call against, as long as CORS is set up, against any domain. The flip side, of course, is that it's possible for malicious JavaScript to look in local storage and see there's a juicy access token, and then again ship it off and use it for other purposes. So where my recommendation is always cookies, and then server side if cookies don't work for the browser scenario. But I understand people have different threat models, and so if you're not bummed by somebody getting an access token, or you think you've locked down JavaScript enough to the browser enough that there's no way that like the marketing person is going to put in a CDN, a script for some third-party SaaS, and that third-party SaaS is going to use NPM, and NPM is going to like have a left pad issue or something like that. Like if you have things locked down enough, maybe local storage is okay.
Okay. Great. Love that. All right. We'll end the session on one last audience question. This is from Martin, and they say, I'm not sure I understand why the long-lived refresh token is better than a long-lived refresh token is better than a long-lived refresh token. If a malicious user gets hold of a refresh token, doesn't that just give them the ability to request a JWT and get the same access as they would have if they had the original JWT?
It's a great question. So the answer is that because the refresh tokens go against the user API, we know a little bit more. So we can do things like watch to see if a refresh token is used twice. We can do things like see where a refresh token request is coming from and build a little more intelligence into that. In OAuth 2.1, which is the next generation of OAuth, which has been moving through the RFC process for a couple of years, they actually recommend that all refresh tokens are either one-time use or they are bound to the client cryptographically. So that was kind of their answer, is you can make refresh tokens more secure because you're building in the security in one place in the user API rather than having it be the responsibility of the to API and the reminder API and all the other APIs. You can make it more secure. But it's a great question, because it is, a common question of like, well, doesn't the refresh token give me the keys to the kingdom? And I guess my answer, if someone really pushed me in that, would be like, hey, if you're really worried about someone stealing a refresh token from the client, put it all server side, right? And just use web sessions, and then you have to deal with session writing, but like you don't have to deal with anything else.
Right, exactly. It seems like if you're going to take this pattern, that it's, I mean, you have to figure out where is your line where you're comfortable with the risk, because you never have zero risk, essentially, right?
You can't trust clients, right? I mean, that's at the end of the day. I hope all the audience knows that anybody, anytime I actually worked at a startup a couple of years ago, many years ago, actually, now, that was trying to like encrypt JavaScript, right? So that it could not be like tampered with or modified. And you just can't do that at the end of the day, because the runtime needs to be able to read and run the JavaScript. You're always going to have an attack vector from the client. So if you're really, really worried about access tokens or refresh tokens being misused, then you got to put them on the server.
Mm-hmm.